Okay, so these are the measures of central tendency plus a bit of hypothesis making and a bit of histogram drawing. So you already know mean, median, mode. Those three are measures of central tendency. Now, how do we apply that to making hypothesis or making conclusions? Now, those three are not really enough, pero at least you can have like a little sense of what types of data you are looking at or what the data is giving you. Okay, let's talk about histograms. So these are three examples here of histograms, no? And there is a so-called skewness or lack of symmetry whenever we draw our histograms. Now, one sec. Medyo na-weird to. Let's see. Let's show the axis of these histograms. Okay, so the vertical axis is your frequency. So when we say frequency, that's how frequent or how often that data appears in your data set. So since we have mentioned data, your horizontal axis is your data, or you can also say values. Okay, so from our examples in class, you would say that, okay, the grades of our classmates are 80, 90, 90, 91, 92, 92, 92, 93, like that, diba? So those will be your data. It doesn't necessarily have to start at 0, but of course, the lowest value will be found along the left side of your horizontal axis. Meanwhile, the highest values will be found at the right side of your horizontal axis. Now, earlier I've mentioned about the grades of our classmates. So, let's say we start at 89 and there's only one classmate who got 89. So, 1 lang siya sa aton nga frequency. Okay. And then earlier I said 90, 90. So, there are 2 classmates who got 90. So, we have 2 here. And then, let's say for 91, there's only 1 person who got 91. And then, for 93, there were 3 people who got 93. So, 1, 2, 3. So, masunod din siya. Oh, it's exactly like plotting your x and y axis. As it's basically plotting a graph. Okay? It's like plotting a graph. So, I'll get rid of this kay gagamo siya sa aton nga images. Okay? Dun. Now, going back. We have here a histogram that doesn't have skew. Wala siya sang skewness. So, it's a bell-shaped curve wherein the left and the right side are symmetrical. So, same sila basically. And it's said to have a normal distribution. Okay. So, when your histogram is in the normal distribution, your mean, median, and mode are at the highest nga peak sa inyong bell curve. So, mean, median, and mode are somewhere around here or near. Later on, I will have definitions of your normal distribution. It says there nga median and mode, they are near the mean. Okay. So, this depends upon your research or the study that you are making. So, if you intend that, for example, you're a teacher and you want to know that your students are learning at the same rate. So, you want as much as possible nga ang aton nga mean and our median, our mode are quite the same. Kaya makasiling ka, okay, so my students, though same lang ilang learning capabilities, kay jutay lang ang ara sa lowest nga point, kag jutay lang man ang sa highest nga point. So, miyara lang ta siguro kailangan buligan sa may lowest nga point, kag siguro miyara gaka-board na sa klase. So, medyo advanced na siya ya. Pero at least jutay lang siya. And all the other students are learning at the same pace. So, muna siya. Ang image ng aton nga bell-shaped curve which is normal distribution. Now, there's a possibility that your histograms are positively skewed like this or negatively skewed. By the way, this part here and this part here, they are both called tails. Okay, tails. But of course, this is your longer tail. So, longer nga tail. Okay. Okay, I'll get rid of this. So just take note of that. Meanwhile, when your histogram is positively skewed, your mean is higher than your median and mode. Kay higher, di ba yung values, oh? So, mean is greater than median and mode. Okay, meanwhile, when our histogram is negatively skewed, our mean is going to be less than the median and the mode. Naku nga, galain. Kaya because, yeah, it's in the left side where the lower values are. Okay? So, it's not necessarily like a good or a bad thing. It still depends on the research that you are conducting. Okay, so let's go to our definitions. So, our definitions are here, symmetrical. When the skewness is close to 0 and the mean is almost the same as the median. Like we have talked about earlier, skewness is just the lack of symmetry. So, lack of symmetry, that means it's close to 0. Okay? Negative skew, when the left tail of the histogram of the distribution is longer and the majority of the observations are concentrated to the right tail. So, if you can remember earlier, I will draw, no? This is our negative skew. So, check ko lang para sure ball gitara. Negative skew. So, let's go back. So, negative skew natin, this guy. Okay? So, it says here that most of the observations are concentrated on the right tail. So, the frequencies of our data are somewhere around here sa right nga side. And then, longer ang aton nga left tail. Palaba siya ya. Okay. So, in this case, we can also use the term left skewed or left-tailed. Kay laba, diyang diri nga side ho. And the median is greater than the mean as we have showed earlier. Next is the positive skewed. So, when the right tail of the histogram of the distribution is longer, so this part here is longer, and majority of the observations or the data values are more frequent on the lower side sa left tail. In this case, you can say that it's right skewed or right tailed, and the median is less than the mean. Okay. So, yeah, we have an example here, but for the moment, we are not going to draw a histogram because, well, we only have 3, 6, 9, 10. We only have 10 values here, and drawing in a histogram is not really pretty at this point. But, what we're going to do is, mahimo kita hypothesis. Okay. Yeah, before we start about that, let's talk about the hypothesis. You have HO and HA. HO, or zero ni siya, stands for null hypothesis. Okay. And HA is alternative hypothesis. Okay. So, the easiest, kumbaga, hypothesis that you can make is, for null hypothesis, there is no significant difference, diba? Utang ko diya. There is no significant difference. If you can remember in high school, that's what we do. Meanwhile, for alternative hypothesis, you can say there is a significant difference. That. Ito ko gamay sa brush ko. Okay. What this actually means is, ang atong null hypothesis is as expected. So, if you have a basis, then there's no change. Kung ano ang ara sa basis naton, amo man ang nagwa sa values naton. Meanwhile, for alternative hypothesis, that means that there is a new conclusion to be said. So, let's say you begin with the statement nga, the grades of the students are high. So, and then you tally all their grades. And then you say null hypothesis, therefore you say, yeah, their grades are high. That's the null hypothesis. Meanwhile, ang aton nga alternative hypothesis for that is, oh no, their grades are not high. Okay, it can be low or somewhere in the middle, but it's not high. So that's your alternative hypothesis. Okay, so don't forget that. I'll erase this and study this example. Here we have a local study shows most 16 to 18-year-olds spend at least 4 hours every day on their cell phones during the recent lockdowns. We gathered 10 teens in our community and asked them how much time they spend on their phones. So below are their answers, and all these values are in hours, and make a conclusion out of this information. Okay, let's make our hypothesis. So, H0, or the null hypothesis is, hindi ko magamit equal, B. H0, lesson colon lang ko is, yun. So, mathematics, misa nga style, you can say that, diba, according sa study, ang atong na 16 to 18-year-olds spend at least 4 hours every day. So, that means ang atong diri nga mean is going to be 4. Okay? Karon lang, explain ko. Finally, ang aton nga alternative hypothesis is that ang aton nga mu, by the way, it's at least, diba? At least, so that is greater than or equal to 4. Meanwhile, ang aton diri nga alternative hypothesis is ang aton nga mean is less than 4. Okay. Miss, paano na siya Okay. So, we are going to use the symbol mu, which you have seen from last time. Mu natin, of course, is our population mean. Wait, let me just check. Yep, it's the population mean. So, population mean. Meanwhile, x bar is a sample mean. Okay, so assuming that this study has a certain population set, and then they found out that ang aton nga mga 16 to 18-year-olds, they spend at least 4 hours every day. So that means, they expect sila nga, ang number of hours na gina-spend sa 16 to 18-year-olds can be greater than or equal to 4. And that is our null hypothesis. Kumbaga, wala change sa statement nga originally nabutang di. Meanwhile, ang alternative naton is that, kumbaga, the opposite of the statement. So, ang aton nga ihambal is that ang aton nga population mean is less than 4 hours ang ila gina-spend. So, amo ni siya ang mathematical nga pag-present sa ang aton nga hypothesis. Okay. In our class, this is what I'm going to need. Okay. Now, miss, saan ako magamit mu? Saan ako magamit x bar? For now, guys, I will just give you, kumbaga, givens. Okay, givens na to. Actually, ang aton, dili karon nga sumahon is not a population mean, but a sample mean. Kaya ang nakuha lang natin is 10 teens from the community. There should be more than that, di ba? Okay, amo ni siya ha? Amo ni natin nga gamiton sa klase. Okay, let's proceed. As you can see, the number of hours in our data set, wala sila nakapasunod accordingly from lowest to highest. So, let's arrange them. I think I start with 2, 2, 3, 4, 4, 5, 5, 5, apat ka 5, 6, 1, 2, 3, 4. Okay. So, always arrange your values at, kumbaga, highest to lowest order. Okay? Now, let's look for the mean, the median, and the mode. Okay. So, our mean is the total of these guys divided by 3, 6, 9, 10. And I think you should get 4.1. Okay. So, use your calculators and you should get 4.1. Meanwhile, the mode is obvious. It's 1, 2, 3, 4. We have 4 occurrences of 5 hours. Okay? And finally, the median is, we have these two right here. That's 4 plus 5 divided by 2, which should give us 4.5. Okay. It's only because ang ating nga data set has an even number of values. 10 kabilog mo. Kaya ang ating nga median, 2 kabilog man. So, ma-divide kita sa 2. Kung 9 lang na siya abit, isa lang na ang ating nga median, no? As you can observe, I've also used the rule that we talked about in class. Ang aton nga data set, ang ilang excuse me, ang ato nga decimal values is non-existent right here. Wala kita diri values. So, in this case, wala. Limutangan ko disang decimal value nga, how can I explain that? Isa ka decimal digit. Isa ka decimal digit. So, 4.1, 4.5, and 5.0. No? Yeah, just remember that. If, let's say, if ang ato nga data set are 4.0, 3.6, 9.8, no? Ang aton diri nga median, mode, and mean, ang aton nga ibutang dira is 4.10, 4.50, 5.00. Okay? So, madugang kita isa ka digit sa aton nga decimal values. Okay, finally, we have here your mean, your median, and your mode. And as you can see, guys, ang aton nga mean is 4.1. Which is, or, which just proves that the null hypothesis is correct. So, we can conclude, no? So, our conclusion is that, ang aton nga 16 to 18 year olds surveyed, 16 to 18 year olds surveyed in our study spend at least 4 hours every day, blah 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 blah. Okay. So with that, masulod ang inyong English. So, the 16 to 18-year-olds that we surveyed in our study spend at least 4 hours every day. Or, you can also say that our alternative hypothesis is rejected. Dumdum ka muna sa high school, no? Ang aton nga null hypothesis is accepted and our alternative hypothesis is rejected. Otherwise, in a statement that you want everyone to understand, go ahead and make a conclusion like this. Okay? So, once again, arrange nyo tanan yung values from lowest to highest. Kamusang inyong null kag alternative hypothesis based sa aton nga statement. And make it mathematical like this, not really as sentences, no? And then, see if your mean follows whichever of these two and then accept one and reject the other. Okay? So, that's how we do the hypothesis testing. But once again, measures of central tendency is not an accurate way to measure data. That's why we have measures of dispersion, which we will talk about soon enough. Okay? Let's move to another example, this time with histograms. So, example with a bit of hypothesis testing and drawing a frequency distribution graph. So, prepare ko na isang. Okay, there you go. The following are the frequencies recorded after testing a new synthetic crystal that an electronics manufacturer wants to use in their new line of oscillators. They want to adjust their manufacturing processes so that they can create 800 megahertz oscillators. All values are in megahertz. What? Okay, the simple thing is this. HO or H0 and HA is this. Let's see here. Is this? Yeah, I think this is a sample lang. So, sample na to. Cluster. What the company wants is that their oscillators are 800 megahertz. 800 megahertz. Therefore, equal kita. Wala sila nagambal ng at least, at most, or 800 and up, 800 and below. Equal din kita sa 800 megahertz. Okay, next. Ang aton alternative is that hindi siya magpareho sa 800 megahertz. As you can tell, with manufacturing, as much as possible, they want accuracy. They seriously want accuracy. So, it's not equal to 800 megahertz and then they have to look for solutions. Either it's higher or lower. Okay. All our values have been arranged from highest to lowest. So, na-plaster na siya nga daan. Now we have your hypothesis. Okay. So, it's gonna take a while for you to look for the mean, median, and mode. So, I have solved them already. Ang mean naton is 756. megahertz. Kagi, nagali sa previous nga example, wala ko gakabutangan hours, no? Yeah, don't forget to write your units. Lipat ko. So, in this case, ang aton nga mean, once again, is 756 megahertz. Ang aton nga median. So, median, I have found, it's 800 plus 800 because obviously, ang mode natin here is 800. Ang median natin is 800 plus 800 divided by 2. Kaya this is, I think, 1, 2, 3, 4, 5. We have 5, 10, 15, 20, 25. We have 30 samples. And yeah, that's an even number. Therefore, our median is going to be 2 numbers. So, 800 plus 800 divided by 2 is 800 megahertz. Megahertz. Okay. And this is our value. Now, which of these two hypotheses are we going to accept and reject? So, we are going to accept our alternative hypothesis because the mean is not 800 megahertz. It's not 800 megahertz. It's 756. Okay. Now, the boss is going to ask you, wait, according sa aton nga data, ang aton nga median, kag aton nga modes, same lang. So, what can you advise, engineer? Are we going to adjust the crystals to be cut in a way that they perform in a higher frequency or in a lower frequency? Laban sini sila tag-as or laban sini sa ila nugbo, no? Kurog atay mo, charot. So, how do we do this? We are going to use classes. So, isaradaan ko ni Dani nga window, no? Okay. So, we are going to use classes. As you have remembered, we have 30 samples. So, sa 30 na samples, I think I'm going to divide them by 1, 2, 3, 4, 5 classes. So, 5 classes. Looking back, I can start from 600 to 850. Okay. So, ang imuon na natin is pangitaon danay natin ang range. So, 850 minus 600 is going to be 200, wait, 1 second. It's 250. Naglibog pa ako nulo. It's 250 megahertz. So, first step, once again, is look for range. 250 megahertz. Now, I have decided, diba? So, decide the class width. So, ang ako nga class width, din decide ko it's going to be 5. Therefore, it's 250 divided by 5 or 50. 50 ang aton nga class width. Miss, what is class width? That is just the interval from the lowest to the... No, it's the interval between classes. Ano siya? The interval between classes. So, I think it's better to demonstrate, no? From 600, isip ka pa 50. So, it's going to be 649. Listen to 650. Kaya nga dali ko ma-start sa 650 ko. Right? And then, it's going to be up to 699. Okay. And then, 700 to 749. 750 to 799. And then, you have 800 to 850. Can you see? These are all the frequencies that we have talked about earlier. So, pangitaon yung range, decide ka mo sa class width. So, sa akon na nga panglantaw, gusto ko 5. You can go with 6 as well. 30 is divisible by 6 man. Pero, I think kung 6 na classes, ang problema, depende sa inyo. Ako lang nga is 5. So, I think it's either your decision or it's going to be instructed sa inyong activity, no? Okay. From here on, we are going to count the frequency. So, how many times do we see 600 to 649 megahertz in our data list? So, 600 to 649, 1, 2, 3, 4, 5, 6 times. So, we go back here and write 6. And then, you can, pause the screen. Isipan nyo tanan-tanan because I'm going to write down the frequencies afterwards, okay? So, pause the screen, and then I'm going back. The frequencies are 6, 0, 3, 4, and 17. Goy, looking at the table pa lang, you can already tell your boss that, boss, most of our oscillators perform at a higher frequency, so ma-adjust kita gamay. Okay? But sometimes, some bosses really like drawings. Masasadyan sila mag-draw. Okay. So, change color lang ako gamay. Oops. Yep. And we are going to draw histogram. So, frequency, as you can remember, and then, ang diri natin is values. Okay. Because of that, hapos na lang ang pagbutang natin values. Unlike sa kagina nga, maisip kita 600, 601, 602, 603. For the values, we will use classes. So, ang ibutang ko din nga classes are 600 to 649. Wait, I think hindi nikitaon sa inyo. Kaon ko lang. Okay. So, you have 600 to 649. We have 650 to whatever. Kabalo na ka mo, 699. So, hindi ko na pag-isulat ha. Gutok din mo. And then, you have 700 to 749. We have 750 to 799. And 800 to 850. Okay. And then, the frequencies can start from 0. We have 1, 2, 3, 4, 5, and 6. Kiwi naman ako na agad. Okay. 600 to 649, we have 6 oscillators that are like that. 650 to 699, wala. 700 to 749, we have 3. So, tunga-tunga. 750 to 799, we have 4. Okay. And then, 800 to 850, damo-damo, 17. So, it's up here. Okay. And then, somewhere pakato dito, and pakato dito. Our histogram kind of looks like this. Yeah. So, this looks like it's negatively skewed. Looks like it's negatively skewed. Let's see. Ang aton tawagin nga median kag mode, if you could remember, was 800. So, ma-change color. Kliwat. Median and mode naton. Ay, wait. One sec. Wait lang. Okay. So, our median and mode are somewhere around here. And then, if you remember, our mean was 756, which is lapaw-lapaw lang sa 750. Ari di aton nga mean. Okay. So, yeah, let's go back. I-remember nyo na ha. Balikan to atong kagina nga mga definitions sa histogram. Okay? So, sa aton nga histogram, oops, kiwi. Oops. Di mo, ara. Negatively skewed gid sa tuod. Ang mean nato nubo sang sa median ug sa mode. Okay? So, balik ka to. Na. It's negatively skewed. Ang aton nga mean is lower than the mode. And the median. So, you can tell your boss, boss, I've noticed that ang aton nga mean is lower than the mode and the median. Okay? And most of our products, most of our oscillators, since the median and the mode are up here, concentration nila is on the right, we have to adjust our oscillators kay do katag-as gid boss ang ilang frequencies. So, siguro gamay na lang adjust para malabot na si 800 panubo-nubuan ta lang siya. Amo na sa. So, with that, without drawing the histogram, just with calculating your mean, median, and mode, you can tell your boss, in average, our oscillators are not performing well. Hindi sila kalabot 800 megahertz. And then, your mean will tell you lies. Basi si boss niya, bro niya pa sa kaanta na kaya nga ito na mean is 756. But actually, most of your oscillators are higher. So, dapat gali panubuan niyo siya. So, that's why, although you have mean, median, and mode, your histograms are still important. Okay? So, those are just the measures of central tendency. There's another way to make sure na accurate gid ang inyo nga pag-conclude, which is the measures of dispersion. But for now, yeah, that's it.